Hi my dear students, welcome back again. In this lecture, we will be going with the JEE Mains previous year questions from the chapter Relations and from the years 2022, 23 and 2024. We'll start with question number 1. First question is from 4th April 2024. Let a relation capital R defined on set of natural numbers be defined as x1 comma y1 is related to ordered pair x2 comma y2 if and only if x1 less than or equals to x2 or y1 less than or equals to y2. Consider the two statements. R is reflexive. Number 2, R is reflexive but not symmetric. Number 2, R is transitive. Now, in this case, see friends, a relation is said to be reflexive if and only if a comma a belongs to capital R for all a belongs to capital A. Okay. Now, to see this, R is reflexive but not symmetric mean, first we'll go with reflexive. An ordered pair x1 comma y1, if it is related to x1 comma y1, for each x1 comma y1 belongs to capital N, then such relation is said to be a reflexive relation. Okay, so if x1 related to x1 comma y1 related to x1 comma y1, what does it mean? It implies x1 less than or equals to x1 or y1 less than or equals to y2. Sorry, y1 less than or equals to y1, which is always true. For any x1 comma y1 natural numbers, x1 is always less than or equals to x1 or y1 is always less than or equals to y1, which means it is true for every set of natural numbers. So clearly it is reflexive. Now we'll see whether it is symmetric or not. Okay. Now in that case, we'll take one ordered pair. 1 comma 2 is related to 3 comma 4. Yeah, 1, 2, 3, 4 are natural numbers. See this friends. 1 comma 2 is related to 3 comma 4. Implies 1 less than or equals to 2 or 3 less than or equals to, 1 less than or equals to 3 or 2 less than or equals to 4. Clearly, so 1, 2 is related to 3 because it satisfies the given definition. Now, if A comma B is related to C comma D, in that case, C comma D should relate to B comma A comma B. Then only it is said to be symmetric relation. Now, to check symmetry, we'll check whether 3 comma 4 is related to 1 comma 4 or not. For that, see friends, 3 less than or equals to 1 or 3 less than or equals to 1 or 4 less than or equals to 2. Is this true? It's clearly a false statement. It's clearly a false statement. So 3 comma 4 does not relate to 1 comma 2. Clearly it is not symmetric. Clearly it is not symmetric. So clearly statement 1 is true now. Statement 1 is true. Now coming to the validity of the second statement, we have to check whether it is transitive or not. What do you mean by transitive? A comma B related to C comma D, C comma D related to some E comma F. If these two verifies true, then from these two, if A comma B is related to E comma F, then such relation is said to be a transitive relation. So in that case, what we do? We'll take some counter example. We'll take some counter example to say that it is not transitive. Whenever we have to prove that a relation is not transitive or not reflexive or not symmetric, please make sure that you are ready with one particular counter example. So in that case, what the best counter example that can be taken is let's take 3 comma 9 is related to 4 comma 6. Is it true? 3 is less than or equals to 4. 3 is less than or equals to 4. At the same time, 9 is less than or equals to 6. Clear? Now, this is true. In the same way, 4 comma 6 is related to 2 comma 7. 4 comma 6 is related to 2 comma 7. 4 less than or equals to 2. No, but we have R 6 less than or equals to 7. So, these two ordered pairs are in relation. These two ordered pairs are also in relation. Now, to make it symmetry, to make it transitive, we have to check whether 3, 9 is related to 2, 7 or not. See, 3 less than or equals to 2, which is false, or 9 less than or equals to 7. Both are false. This is false, this is false. So it does not. That means 3, 9 does not relate to 2, 7. Is not related to 2, 7. So clearly it is not transitive. Clearly it is not transitive. So that means that relation is reflexive but not symmetric, and it is not transitive. So hence only option C is going to be correct option. Clear, friends? A relation can be reflexive if only A comma A belongs to capital R, for all A belongs to capital A. Symmetric means if A is related to B, in that case if B is related to A, then it is symmetric. If not, it is not symmetric. Next, transitive, A related to B, B related to C, in that case A should compulsorily relate to C, then it is said to be transitive. If not, not transitive. Okay? So answer is option C from 2024, 4th April. Next question, 6th April 2024. They have given again two relations. Let relation R1 and R2 defined on set. There is one particular set. These two relations are defined on the same set. Set of 1 to 20 natural numbers. Be given by R1 is equals to x comma y. R1 is equals to x comma y such that 2x minus 3y is equals to 2. Next, R2 is equals to x comma y such that minus 4x plus 4y is equals to 0. Now in this case, how do we say that let capital M and capital N be the minimum number of elements? They are asking us to, if capital M and capital N denotes the minimum number of elements required to be added in R1 and R2, okay? In order to make the relation symmetric, to make symmetric, they have added some capital M elements in R1 and capital N ordered pairs in R2. Now they are asking us to find M plus N. Then what is the value of M plus N? First we will find what is R1 and what is R2. What are the ordered pairs which are in R1 and what are the ordered pairs which are in R2? Chalo. So R1 is equals to, friends, set of, we have 2x minus 3y is equals to 2, but x comma y should be from 1 to 20 only. X comma y should be from 1 to 20. So if you take 2x is equals to 3y plus 2, 2x is equals to 3y plus 2, then 4 comma 2 will be an ordered pair. 4 comma 2 belongs to R1, correct? See, 2 4s are 8, minus 6, 8 minus 6 is plus 2. Clear? 4 comma 2 is an element belong to R1. Next, 7 comma 4 is an element which belong to R1. 4 comma 2, 7 comma 4, 7 comma 4. Why? Because 2 7s 14 minus 4 3s 12. 14 minus 12 is 2. Next, 10 comma 6. Next, 13 comma 8. 16 comma 10, 18 comma 12, 19 comma 12, 19 comma 12, 4 comma 2, 7 comma 4, 10 comma 6, 13 comma 8, 16 comma 10, 19 comma 12, 19 2s 38 minus 30, 12 3 is 36. 38 minus 36, which is plus 2 only. Okay. So how many number of elements in R1 now? 1, 2, 3, 4, 5, 6. Clear. Now, capital N, there are capital M elements to be added to R1 to make it symmetric. So, minimum number of elements, that too. That means to make it symmetric, friends, if 4 comma 2 is in R1, to make it symmetry, 2 comma 4 should be added, correct? So we have to add 2 comma 4, we have to add 4 comma 7, we have to add 6 comma 10, we should add 8 comma 13, we should add 10 comma 16, we also should add 12 comma 19. So how many number of elements we have added? 6 elements. So that means capital M is equals to 6 we got. Chalo, now we'll find R2. R2 is nothing but minus 5x plus 4y, that is we can say 4y is equals to 5x friends. 4y is equals to 5x. Okay. So in this case, what are all the ordered pairs? 4y is equals to 5x means we can say 4 comma 5 is an element. Yeah. When x is 4, 4 5 is 20, y is also y is 5, then 4 5 is 20. Then 8 comma 10, 4 2s are. Next 4 3 is 12 comma 15. Next 4 4s are 16 comma 5 4s are 20. So these are the 4 elements in R2. 4 comma 5, 8 comma 10, 12 comma 15 and 16 comma 20. Now we have 4 elements in R2. To make it symmetric, what are the elements to be added? We have to add 5 comma 4. We have to add 10 comma 8. We have to add 15 comma 12 and 20 comma 16. Okay. So that means how many elements we have added? Capital N is equals to 4. Now they are asking us to find m plus n value, which is 6 plus 4 is equals to 10. M plus n is equals to 6 plus 4, which is equals to 10. The answer is option A. Clear friends? Each question we see, if a question from relations, it should be from either it is reflexive or symmetric or transitive, checking whether it is symmetric or not, checking whether it is reflexive or not, or transitive or not, finally equivalence or not. Next question. This is from 6th April 2024. Coming to this question, let A is equals to set of 1, 2, 3, 4, 5. Fine. Let R be a relation defined on set A, defined such that x is related to y if and only if 4x less than or equals to y. So this is our relation definition of the relation. This is the relation definition that we have. So let m be the number of elements in R and n be the minimum number of elements required to a same story again. They have given n be the number of elements, minimum number of elements to be added in this R so that to make it symmetric. Now same they are asking m plus n only. Chalo, first let's find what is R. Okay. R is equals to set of 4x less than or equals to 5 means 1 comma 1 will be in it, x1 y1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 will also be in it. Okay. Next 2 comma 2, yes, 2 comma 2 will be in it, 2 comma 3 will be in it. Let's go in this order. 2 comma 4, 2 comma 5, 3 comma 3 will be in it, 3 comma 4 will be in it. Next 3 comma 4 will be in it, 3 comma 5 also will be in it. Yes. 4 3s are 12, 12 less than or equals to 15. 4 3s are 12, 12 less than or equals to 5 3s are. Now next 4 comma 4. Yes, 4 comma 4 will be in this. 4 comma 5 will also be there. 5 comma 4, 5 comma 5 will also be there. So total number of ordered pairs, how many do we have? Number of elements in R is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh God, 16 elements we have. So this 16 is nothing but, what is 16 now? M be the number of elements in R. So M is equals to 16. We got M value friends. Clear? Now what is N? N is the minimum number of elements to be added in R so that to make R as symmetric relation. We already know clearly that a relation to be symmetric, that means if A comma B belongs to R, B comma A also should be part of R. So we have to add 2 comma 1. Correct? We have to add 2 comma 1, 3 comma 1, 4 comma 1, 5 comma 1. Okay, next 3 comma 2 we have to add, 4 comma 2 we have to add, 5 comma 2 also should be added. Next 4 comma 3 should be added, 4 comma 3 should be added, 5 comma 3 also should be added. 4 4 4 5 5 4 is already there. So what are the minimum number of elements that we have to add? 2 comma 1, 3 comma 1, 4 comma 1, 5 comma 1, 3 comma 2, 4 comma 2, 5 comma 2, 4 comma 3 and 5 comma 3. 1 2 3 4 5 6 7 8 9. So minimum number of elements to be added in R to make R symmetric is 9 elements. Now they are asking us to find the value of m plus n, friends. So that is clearly m plus n is equals to 25. Answer is 25. Clear? Next question. A set given 2, 3, 6, 8, 9, 11. Set B given 1, 4, 5, 10, 15. R be a relation on A cross B. Okay. Defined by AB, ordered pair AB related to CD if and only if 3AD minus 7BC is an even integer. 3AD minus 7BC is an even integer. Okay. Now what are all the options? An equivalence relation, fine. Reflexive and symmetric but not transitive, fine. Reflexive but not symmetric, transitive but not symmetric. What do we do? First, usual definition. A relation to be reflexive, A comma A should be belongs to R for all A belongs to capital A, correct? That is AB related to AB. We'll check whether AB is related to AB or not. So, AB related to AB means 3 times of AD, 3 times of AB minus 7 times of BC is again AB. 3AB minus 7AB which is minus 4 times AB, clearly it is even integer, friends. Clearly even integers. So this is for sure, it is always reflexive. It is reflexive. So relation R is reflexive. Fine. Next, to make symmetric, what to do? To make symmetric, AB related to CD implies 3AD minus 7BC. 3AD minus 7BC is an even integer. Okay. Okay. Now, what we have to check? We have to check CD related to A comma B or not. So CD means what it becomes? 3 times of AD, that is BC, 3BC, fine. Next R, 3BC minus 7 times what we have? BC means AD. We do one thing, friends. We'll add, anyhow this previous one is even integer only. This is even integer only. So if you add an even integer to this even integer, result should also be even. There won't be any change. So let's add, what we add? Let's add 4BC plus 4AD. Okay. Now clearly you see this should be an even integer, correct? 4BC plus 4AD. We have added 4BC and 4AD to this. So minus 7BC plus 4BC is 3BC minus, now 3AD plus 3AD plus 4AD we have. So actually we'll do one thing. Instead, to get minus 7AD, what can be added? We can add this. We can add 3 plus 4 7 minus, okay, we do one thing. This only will add. Okay. So 3AD plus 4BC. 3AD plus 4AD is 7AD. Clearly. Minus 7BC plus 4BC is minus 3BC. So that means when you have added 4BC and 4AD to an even integer, the result should be even. That means 7AD minus 3BC is clearly an even integer. Okay. Now this is an even integer. We know that it is even. So 7AD minus 3BC is an even integer. But what is CD related to AB? 3BC minus 7AD, which is negative of this. If this is even, negative of this will also be an even. Correct? So that means this will also be an even integer. This will also be an even integer. So hence it is symmetric. So clearly this is also true. Hence it is reflexive, symmetric. We have options equivalence, reflexive, symmetry, but no. So we have to check, no other go, we have to check for transitivity. Okay. For that, counter example. We can't go by definition. For that, we'll go by counter example. So 2, 5 is related to 6, 8. We'll see. 3AD, that is 3 into 2 into 8 minus 3AD minus 7BC. 7 into 5 into 6. Clearly it is an even integer. Yes, some 2k. Because see, 8 into something even minus even, it is even integer. Okay. Next, another 6, 8, 6, 8, 9, 1 is also related to R. Let's see. That is 3 times of AD. 6 into 1 minus 7 times of BC. 8 into 9. So clearly see friends, 6 into something, that is even minus even. This is also some even only. Okay. So that means 2, 5 related to 6, 8. 6, 8 related to 9, 1. So according to be transitive, what should happen? 2, 5 should relate to 9, 1. Clear? So that becomes 3AD. 3 times of AD. 3AD. 3 into 2 minus 7 times of 5 into 9. Friends, clearly 3 2s are 6 is an even. Minus 7 5 35, 35 9 is odd. Even minus odd is an odd integer. So that means this 2, 5 is not related to 9, 1. 2, 5 is not related to 9, 1. Hence it is not transitive. Therefore, the relation is reflexive and symmetric but not transitive. Option B is the correct answer. Okay. Next question. Consider the relations R1 and R2 defined as A is related to R1B, such implies A square plus B square is equals to 1 for all A comma B belongs to capital R. R2 given A plus D is equals to B plus C for all AB related to CD belongs to N by N. Then R1 and R2 both equivalents, only R1 equivalents, only R2 equivalents, neither R1 nor R2. We'll see friends. First, we'll go with this R1. Now, we'll check R1. R1 to be equivalence relation, first we'll check for reflexive. Reflexive means A comma A belongs to capital R. So put A square plus A square is equals to 1. 2A square is equals to 1. A is equals to A square is equals to 1 by 2. A equals to plus or minus 1 by root 2. So clearly, it is reflexive only, it is true only for A is equals to either 1 by root 2 or minus 1 by root 2, but not for A comma B belongs to capital R. That means, see, 0 comma 0 is not in R, 2 comma 2 is not in R, 3 comma 3 is not in R. Clear? So it is only true for 1 by root 2 comma 1 by root 2 or minus 1 by root 2 comma 1 by root 2. That means it is not reflexive. It is not reflexive. It is not reflexive. Okay. So if it is not reflexive, then there is no checking for symmetric and transitive. Why? Because they have given only regarding equivalence relation in the options. So if it is not reflexive, then it is not equivalence relation. Okay. So clearly R1 is not equivalence. R1 is not an equivalence relation. Equivalence relation. Okay. Next case. We'll go with our R2. Now coming to R2 friends, A comma B related to C comma D implies A plus D is equals to B plus C. For all AB belongs to natural numbers only. Okay. First, reflexive. Here also we'll check for reflexive. A comma B related to A comma B implies A plus D, that is A plus B is equals to B plus A. Clearly this is true for any value of A comma B. Okay. So it is reflexive. Now symmetric means AB related to CD The implies A plus D is equals to B plus C. Now if CD related to A comma B, what happens? CD related to A plus D, that means C plus B is equals to B plus C, B here D plus A. See, this is nothing but A plus D is equals to B plus C only. Just in reverse order we have written. So that means CD is also related to A comma B, hence it is symmetric. Reflexive, symmetric, transitive important, friends. Transitive is important. We'll check transitivity. So clearly if AB related to CD, A plus D is equals to B plus C, and CD related to some E comma F, which implies CD related to E comma F means what happens? What? A plus D is equals to, that is C plus F is equals to, C plus F is equals to B plus C, D plus E. Okay? And we also have AB related to CD means A plus D is equals to B plus C. We do one thing. Actually what we need, A comma B related to E comma F, double implies what we have to get, A plus F. We should get A and F is equals to B plus E. For that we do one thing, ma. We'll add this one and this one. These two are two true statements, no? We'll add these two. So when we add, what happens, you see? A plus D plus C plus F is equals to B plus C plus D plus A. Okay? B plus C plus D plus E it is. D plus E. C, D. So A plus F is equals to B plus E. That means clearly it is transitive, friends. Clearly R2 is transitive. So R1 is not transitive. R1 is not equivalence relation. R2 is reflexive, symmetric and transitive. That means only R2 is an equivalence relation. Only R2 is an equivalence relation. Clear, ma? Next question. Let S is equals to 1 to 10. Suppose M is the set of all the subsets of S. Set of all subsets is power set. Then the relation R is equals to A comma B such that A intersection B not equals to 5. A intersection B not equals to 5. Clearly, ma? First we'll see reflexive. See, any intersection, A intersection A is always equals to A, which is not 5. But as they said, A comma B belongs to M, no? Set of all subsets means null set will also be subset of every set, no? So phi, that means null set will also be an element of this M. So if what is now phi intersection phi, which is phi, that means clearly it is not reflexive. Even any statement, if it fails for one single statement, any statement, if it fails for one single condition, then it is a failed statement only. So it is not true for A is equals to 5. That means clearly it is not reflexive. Okay, good. We'll go with symmetric. Symmetry not necessary to check, ma. See, if A intersection B is not 5, implies B intersection A is also not 5. Clearly, this is what commutative law states. Okay, so it is clearly symmetric. Coming to symmetry, yes, our relation is symmetric. Now we'll check for transitivity. To check for transitivity, what we have to do? A intersection B not equals to 5. Okay, and B intersection C not equals to 5. Now if we can able to say A intersection C not equals to 5, then it is said to be transitive. But if A intersection B not 5, B intersection C not 5, can we say A intersection C not 5? Not necessarily. So this statement is not necessarily true. Not necessarily true. So that means you can't say that it is a true statement. A statement is said to be a true statement if it is true in all the conditions. In all the conditions. But this may be true, may not be true. Clear? Okay, so hence it is not transitive, that means not reflexive, only symmetric, which is option D. Option D is the answer. Clear? Next question. Let a relation defined on integers such that AB related to ordered pair AB related to CD if and only if AD minus BC is divisible by 5. AD minus BC divisible by 5 means, friends, AD minus BC divisible by 5. So is reflexive neither, so anyhow they are asking again all reflexive, symmetric, transitive. First we will check for reflexive. Reflexive means AB should relate to AB. So if AB is related to AB, what happens? What will be the relation? AD. AD means AB minus AB, which is 0, clearly divisible by 5. Clearly divisible by 5. That means it is reflexive. Clear? So a relation is said to be reflexive if A comma B is related to A comma B. Each ordered pair is related to itself. AB minus AB, it is 0. Clearly 0 is divisible by 5, then it's fine. Okay. Next, symmetric. We'll see for symmetric. What our symmetric statement says? A comma B. If A comma B is related to C comma D. That means what? A comma B related to C comma D is AD minus BC. AD minus BC should be some divisible by 5. So 5k. Okay. Now we'll check for CD. Either it is related to A comma B or not. C comma D. Either it is related to A comma B or not. Now CD related to A comma B means what will be statement? CD related to A comma B. AD minus BC, that is BC minus AD again. Oh, it is clear. If AD minus BC is 5k, BC minus AD is minus 5k. That means clearly it is also divisible by 5 now. Yeah, it is also again divisible by 5. So it is also symmetric. It is also symmetric. Now coming to transitivity. Okay, we'll see this, friends. We can't prove it, we can't verify it by using the statement. For that we have to show some counter example in which case it is not transitive. Okay. Now coming to transitivity, we have 1 comma 1 is related to 0 comma 0. Yeah. 1 comma 1 is related to 0 comma 0, that is 1 into 0, 0 minus 1 into 0. So 0 is divisible by 5, fine. Next, 0 comma 0 is related to 2 comma 8. 0 comma 0 is related to 2 comma 8. Okay. So because 0 into 8, 0 minus 0, this is also divisible by 5. Now what about 1 comma 1 and 2 comma 8? See AD, 8 into 1, 8 minus BC, 8 minus 2 is 6, clearly not divisible by 5. Not divisible by 5, therefore it is not related to 1 comma 1 is not related to 2 comma 8, hence it is not transitive. So it is reflexive, symmetric, but not transitive, which is option D. Option D is the correct statement, correct answer. Clear? Next question. R is the smallest equivalence relation on the set 1, 2, 3, 4 such that 1 comma 2, 1 comma 3 is subset of R, then the number of elements in R is, oh God, smallest equivalence relation having 1, 2, 3, 4 elements means, friends, R should have, it should be reflexive. So to make it reflexive, 1, 1, 2, 2, 3, 3, 4, 4 should be there, correct? Okay. Now they said 1 comma 2 is also there. Okay, 1 comma 2 is there. To make it symmetric, 2 comma 1 should be there. Okay. Next, if 1 comma 3 is there, to make it symmetric, 3 comma 1 also should be there. Next, what else do we need? Is it transitive? We have to make it transitive also. if R is the smallest equivalence relation on the set 1, 2, 3, 4. So 1, 2 we have, 1, 3 we have. Now for that, my dear friends, for that, to make it transitive, see, to make it transitive, what else do we need? 1, 2 is related to R, 2, 1 is also related to R, 1, 3 is related to R, 3, 1 is also related to R. Now 1, 2, 2, 1, 1, 3, so 2, 3 should be there. 2, 1, 1, 3, so 2, 3 should be in our R to make it transitive. Now as we have 2, 3, again to make it symmetric, 3, 2 should be there. Clear? 2, 1, 1, 3, 1, 2, 2, 3. That's it. So with that, this relation will be the smallest possible equivalence relation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Answer is option C, 10. Clear, friends? Because we have, see, 1, 2 and 1, 3 should be, these two elements should be there. So if these two are already there, to make them symmetric, we have added 2, 1, 3, 1. Now, when you have added 2, 1, 1, 3, AB, BC, AC will check. That is 2, 3 should be added. If 2, 3 is there, to make it symmetric, again 3, 2. So this is what we say, it is reflexive, symmetric and transitive. Hence it is the smallest possible equivalence relation on this. With these two subsets will be having how many elements? 10 elements. Next, let A is equals to set of 1, 2, 3, 4, 5, 6, 7. Then the relation R is equals to set of ordered pairs x, y such that x plus y is equals to 7. Okay? X plus y is equals to 7. This is what we are supposed to see. X plus y should be 7. First equivalence. So that means we have to check all, friends. First we will check for reflexive. To make it reflexive, x plus x is equals to 7. 2x, x is equals to 7 by 2. X is equals to 7 by 2. So clearly 7 by 2 is not an element of this. So you can't, it is not reflexive. Okay? Symmetric. Friends, common sense. If x plus y is equals to 7, for sure y plus x will also be equals to 7. For sure y plus x will be 7. So it is symmetric but not reflexive. Now we'll check for transitive. Okay? X plus y 7. X plus y, see, x plus y 7 means we can just check counter example. 1, 6. 1, 6 belongs to R. That is 1 plus x is equals to 7. 6, 1 also belongs to capital R. Now 1, 6 belongs to R, 6, 1 belongs to R. In this case 1, 1 will check, but 1, 1 does not belongs to R, hence it is not transitive. So it is only symmetric but not reflexive and transitive. Hence option D is the correct answer. Option D is the correct answer. Next question. A is equals to set of 2, 3, 4, B is equals to set of 8, 9, 12. Then the number of elements in the relation R is equals to set of ordered pairs of A1, B1, A2, B2 belongs to A cross B, A cross B only. A1 divides B2, A2 divides B1. So here we have two sets, friends. First, set A and set B. Set A has three elements, 2, 3, 4. Set B also has 3 elements, 8, 9, 12. Now relation A1, ordered pair A1, B1 is related to ordered pair A2, B2 if A1 divides B2 and A2 divides B1. Okay? And A2 divides B1. So that means A1 divides B2 means A1 should be taken from this, B2 should be taken from this. See, friends. 2 divides 8, 2 divides 12, 3 divides 9, 3 divides 12, 4 divides 8, 4 divides 12. So each element from A has two, you can take 2 ordered pairs. Each element with A can get 2 ordered pairs in B. It can pair up with 2 elements in B. That means 3 2s are. So with A1 comma B2 we get 3 into 2, 6 elements. Okay. Now with the A2 comma B1, A2 divides B1. Same story again. A2 if I take 2, B1 can be either 8 or 12. So in that way, each element in capital A can associate with the 2 elements in B. 3 2s are 6. Now total number of ordered pairs, to get ordered pairs, this and this, no, 6 into 6, which is equals to 36. 6 into 6 is equals to 36. So number of ordered pairs in that relation, in that R, will be 36. As we have and, friends, we use multiplication principle of counting, then we get, so total number of ordered pairs will be 6 6 are 36. Next question. Set A 1 3 4 6 9, set B 2 4 5 8 10. Let R be a relation be defined on A cross B such that R is equals to set of ordered pairs so and so, A1 less than or equals to B2 and B1 less than or equals to A2. Acha. Then the number of elements in the set R is, see friends, here also almost same case. First we will take, there are two sets, set A, set B. Set A has 1, 3, 4, 6, 9. Okay. Set B has 2, 4, 5, 8, 10. What is our relation now? A1 less than or equals to B2 and B1 less than or equals to A2. A1 should be from this, B2 from this. A1 less than or equals to B2 means, friends, 1 is less than or equals to 2, 1 less than or equals to 4. So 1 2, 1 4, 1 5, 1 8, 1 10. 1 2, 1 4, 1 5, 1 8, 1 10. With 1 we can form how many ordered pairs? 5 ordered pairs. With 3 less than or equals 3 4, 3 5, 3 8, 3 10. 4 ordered pairs. With 4 less than or equals to, no, so 4 4, 4 5, 4 8, 4 10. Next with 6 less than or equals to 5, no, 6 8, 6 10, only 2. With 9 less than or equals to 10 only 1. So how many ordered pairs do we have now? 5 plus 4 9, 9 plus 4 13 plus 3 16. Okay, this is with respect to A1 B2. What they said, B1 less than or equals to A2. B1 less than or equals to A2 means B1 from this, A2 from this. B1 less than or equals to 2 less than or equals to 1? No, but 2 3, 2 4, 2 6, 2 9. So we can take 4 elements from 4 ordered pairs with 2 as B1. Next 4 less than or equals to 4, 4 4, 4 6, 4 9, 3 elements. 5 6, 5 9, 2 elements. 8 9, only 1. That's it. So 4 plus 3 7, 7 plus 2 9, 9 plus 1 10. So same story again, as we have and, friends, we use multiplication theorem. So total number of elements in R will be 16 into 10, which is equals to 160. So the answer is 160. Clear? Next question. Now coming to this question, let R be a relation on capital R given by R is equals to ordered pairs of A comma B such that 3A minus 3B plus root 7 is an irrational number. Okay. Now the relation symmetric, reflexive, transitive. First we will go for reflexive. Reflexive means A comma A belongs to capital R. So 3A minus 3A plus root 7. 3A gets cancelled. Root 7. Root 7 is an irrational number. Clearly it is an irrational number. Q dash. Okay. So every ordered pair is related to itself. That means every element is related to itself. Hence it is reflexive. Okay. Now coming to symmetric. (3a minus 3b plus root 7 is equals to is an irrational number, it seems. So let A comma B belongs to capital R. A comma B belongs to capital R means 3a minus 3b plus root 7 is an irrational number. Is an irrational number. Okay. Now let's do one thing, friends. if it is an irrational number, let this be is equals to some root 7. Okay, 3a minus 3b is equals to some root 7. Root 7 plus root 7 is clearly irrational number. Now what about b? B comma a? B comma a implies 3b minus 3a plus root 7. Now see this, if 3a minus 3b is root 7, 3b minus 3a is minus root 7. So minus root 7 plus root 7, which is equals to 0, clearly does not belongs to set of irrational numbers, does not belong to set of irrational numbers, hence it is not symmetric. Hence it is not symmetric. Now in the same way we can check for transitivity also. For transitivity we have to check one counter example. So what is that counter example? First, root 7 comma 1 belongs to capital R. Why? See, 3 root 7 minus 3 plus root 7. Clearly it is irrational number. Okay, that is 4 root 7 minus 3. Another 1 comma 4 root 7 by 3 is also an element of R. 1 means 3 minus 4 root 7 by 3, that is minus 4 root 7 plus root 7 is again an irrational number. Now what about root 7 comma 4 root 7 by 3, friends? So clearly 3 into root 7, 3 root 7 minus 3b means 3 gets cancelled, minus 4 root 7 plus root 7. This is 4 root 7 minus 4 root 7, which is 0, which is not transitive. So clearly it is not transitive. So it is only reflexive and it is not symmetric, not transitive. Hence the answer is option C. Clear? Reflexive but neither symmetric, not transitive. Okay? So one thing you have to understand, friends, the thing is, the only thing to say that it is not something, either go by definition. If you are not able to get some conclusion by definition, go with some counter example. Next question. Now coming to this question, let P of S denote the power set of S. Power set of S means set of all subsets of the given set. Define the relations R1 and R2 on P of S such that A is related to R1B, A is related to B under R1. Then if A intersection of B complement union B intersection of A complement is phi, then what about? See guys, just by using definition we can say, if it is reflexive, first R1 will check for R1. Now R1 reflexive means what we do, in place of A we put A, in place of A comma B we put A comma A. So A intersection A complement is null set, union B A intersection phi union phi is phi. Clearly it is true, it is reflexive. Now coming to symmetric, A intersection B complement union B intersection A complement is phi means symmetric means just replacing A in place of B and B in place of A. This is also true. Okay, see what do you get? A intersection B complement in union B intersection A complement. Symmetric means B intersection A complement, that is already in this, and this is A intersection B complement. So this is true, it is symmetric also. Now transitivity. Coming to transitive, friends, first AB related to A comma B, A is related to B and B related to C. From there we have to check for A related to C. So A intersection B complement union B intersection A complement is equals to phi. Before that, see, the union of two sets is phi means each set should be a null set. Is that okay? The union of two sets will be null set only when each set should be a null set. That's it. So this should be null set, this should be null set. This should be null set, this should be null set. Clear? So A intersection B complement is null set now. And C comma D, I mean B related to C means B intersection C complement union C intersection B complement is again null set. That means this is also phi, this is also phi. So clearly, friends, from these two statements we can easily say that A intersection C complement is equals to C intersection A complement, sorry, is not equal, I mean union this union C intersection A complement is always equals to null set only, because this is phi, which is nothing but phi. So hence it is reflexive, symmetric and transitive. R1 is an equivalence relation. Coming to R2, R2 is also same case. A intersection A complement union, A intersection A complement is A union A complement is equals to A union A complement. It is reflexive. Symmetric means anyhow it is already symmetric by definition. A union B complement is equals to B union A complement. Fine. Now transitive means again same. A union B complement is equals to A union B complement is equals to B union A complement for A comma B. Next B comma C, B union C complement is equals to C union A B complement for B comma C. From these two we can say clearly A union C complement is equals to C union A complement. That means these two relations are equivalence relations. Both the relations are equivalence relations. Okay. Next case, next question. The relation are such that ordered pair of A comma B, if GCD is 1, GCD is 1, okay. Is it going to be reflexive? Is it going to be reflexive? Suppose it is true for only one, but suppose if I take 2 comma 2, 2 comma 2 it does not belongs to R. Why? Because GCD of 2 comma 2 is 1 and 2 itself, okay. So GCD of 3 comma 3 is 3. So it is not reflexive. Fine. It is not reflexive. It is not reflexive. Now coming to symmetric. Clearly, my dear friends, if you see 2 comma 1, 2 comma 1 belongs to capital R. Why? Because GCD of 2 comma 1 is 1. Okay. Now what about 1 comma 2? Which implies 1 comma 2 GCD is also 1, but they said 2A should not be equals to B. So if A is 1 and B is 2, 2A is 2. 2A not equals to B. That means 1 comma 2 does not belongs to R. Hence it is not symmetric. Hence it is not symmetric. Okay. Next, transitive. Friends, 2 comma 3 is related to R. 3 comma 8 is related to R. Now from these two, what about 2 comma 8? Does not related to R, because GCD of 2 comma 8 is not 1. Okay. Hence it is not reflexive, not symmetric. Hence it is not reflexive, not symmetric, not transitive. So among the options, reflexive but not symmetric, no. Transitive but not reflexive, no. Symmetric. So they said only option D, which is true, because it is neither symmetric, not transitive and not reflexive also. But among first 3 options they have given something. So option D is the correct answer. Okay. This was asked in 24th Jan 2023. Next question. Let R be a relation defined on N as if 2A plus 3B is a multiple of 5. 2A plus 3B. So first we will check for reflexive only. 2A plus 3A is equals to 5A. Clearly it is multiple of 5. Therefore it is reflexive. Given relation is reflexive. Okay. Next. Symmetric. Symmetric means A comma B related to R implies 2A plus 3B should be equals to some. Okay. Next, what about B comma C belongs to R implies 2C, yeah, 2A, 2B plus 3C. Symmetric, no? For symmetric it is only B comma A belongs to capital R implies 2B plus 3A. But we are not sure about whether it is multiple of 5 or not. For that, let's take it is some M. Add 3B plus 2B is 5A. 2A plus 3A is 5A. This is equals to 5K plus M. So clearly M is equals to some 5 times of A plus B is some 5N minus 5K, which is clearly a multiple of 5. Yeah, so hence it is also symmetric. That is A comma B belongs to R implies B comma A also belongs to R. Now coming to transitive. For transitive what we do? For transitive what we do? A comma B related to R1, R, that is 2A plus 3B is equals to 5K1. B comma C related to R, 2B plus 3C is equals to 2B plus 3C is equals to what? 5K, 5K2. Now if I add these two friends, if I add these two, clearly 2A plus 3C, 3B plus 2B is 5B is equals to some 5M. So 2A plus 3C is also equals to 5M minus 5B is equals to 5K only. That means 2A plus 3C is also a multiple of 5, which implies A comma C is related to R, hence it is transitive also. Therefore the relation is symmetric, reflexive and transitive, hence it is an equivalence relation. Clear? Next question friends. The minimum number of elements that must be added to the relation R is equals to set of A comma B comma B comma on the set, so that it becomes symmetric and transitive it seems. Okay, symmetric and transitive. First, A comma B, B comma C. The minimum number of elements to add that must be added to make it symmetric and transitive. See friends, to make it symmetric we need B comma A. To make it symmetric we need C comma B. Okay, that must be added only. Now transitive also it is there. So AB BC means we have to add A comma C. When we have added A comma C, C comma A also should be there. Correct? Now AB BA means to make it transitive again A comma A should be there. BC CB means B comma B should be there. AC CA means A comma A also should be there. So clearly, what are how many number of elements that we have added now? 1, 2, 3, 4, 5, 6, 7. So we should add 7 elements to make it symmetric and transitive. Next question. Let R be a relation on n by n defined as AB related to CD if and only if AD of B minus C is equals to BC of A minus D. We can do one thing. First, to check whether it is reflexive or not, what we do? We put A comma B should relate to A comma B. So A comma B means that is AB of B minus A is equals to BC means again BC means AB of A minus D, A minus B. AB cancel, B minus A not equals to friends, B minus A not equals to A minus B, therefore AB is not related to AB, therefore it is not reflexive. Relation is not reflexive. Next, we will check for symmetric. We do one thing, we will divide B minus C by BC, B minus C by BC, see AB related to CD implies, double implies B minus C by BC, that is B minus C divided by BC. B minus C divided by BC should be equals to what? A minus D by AD. This is what the relation. Now B minus C by BC is 1 by C minus 1 by B is equals to 1 by D minus 1 by A. Okay. Now CD related to A comma B means A comma B. CD related to A comma B means 1 by C. So that is 1 by A minus 1 by B. B is 1 minus 1 by D is equals to 1 by B minus 1 by A, that is 1 by C. Clearly, if I just multiply with a negative sign both, this I can write this as 1 by D minus 1 by A is equals to 1 by C minus 1 by B, which is true from this. So clearly it is symmetric. It is symmetric. Now check for transitive. If to check for a transitive, what should we do? AB related to CD. So from here we get clearly 1 by C minus 1 by B is equals to 1 by D minus 1 by A. Next, CD related to some EF. CD related to E comma F mean, so 1 by E minus D, in place of B we have 1 minus 1 by D is equals to 1 by D, that is 1 by F minus 1 by C. So from these two, can we get the relation? Can we get what we are supposed to get? AB related to E comma F. So 1 by A, 1 by C minus 1 by, that is 1 by E minus 1 by B is equals to 1 by D, 1 by F minus 1 by A. Can we get this from this? 1 by E minus 1 by B. If I add these two, no, we will never get this. So from these two, we can never conclude this particular equation. Hence, clearly it is not transitive. Therefore, the relation is only symmetric but neither reflexive nor transitive. It is option B, friends. Clear? Next question. 19th question. Set A is 1, 2, 3 to 20. Let R1 and R2 be two relations on A such that R1 is equals to AB. B is divisible by A. B is divisible by A. Okay. We'll find first R1. B divisible by A means, friends, what do you mean by B divisible by A? So what are all the elements that we will be having? B is divisible by A. 1 comma 1, 1 comma 2, 1 comma 3, and so on till 1 comma 20. Okay. Next, coming to 2 comma 1, no, 2 comma 2, 2 comma 4, 2 comma 6, and so on till 2 comma 20. Okay. Next, 3 comma 3, 3 comma 6, 3 comma 9, and so on 3 comma 18 we get. In the same way, 4 comma 4, 4 comma 8, 4 comma 12, and so on 4 comma 20. 5 comma 5. Next, 5 comma 10, 5 comma 15, 5 comma 20. 4 elements. 6 comma 6, 6 comma 12, 6 comma 18. 7 comma 7, 7 comma 14, 8 comma 8, 8 comma 16, 9 comma 9, 9 comma 18, 10 comma 10, 10 comma 20, 11 comma 11, oh my god, 12 comma 12, 13 comma 13, 14 comma 14, 15 comma 15, 14 comma 14, 15 comma 15, 16 comma 16, 17 comma 17, 18 comma 18, 19 comma 19, 20 comma 20. So 20 elements till here. This is 20, this is 10, this is how many? 3 1s are 3 6s are 8 elements, 4 5s are 20. Next till here 5 4s are 20, 5 4 plus 1, this row 5, 6 3s, 3 plus 2 5, 7 2s 2 plus 4 5, 1 2 3 4 5, 5, 1 2 3 4 5, again 5, 20 30, 30 38, 38 48, 48 58, 58, so how many elements do we have? 20, 20 plus 10 30, 3 1s are 3 6s are 18. This particular case is 6s, friends. 3 6s are 18. Okay. So 20, 10, 30, 40, 50, 60, 60 plus 6, that means total number of elements in R1 will be 66, friends. Okay, 66. Next R2 is A such that A is an integral multiple of B. Okay, A is an integral multiple of B. Okay, then R number of elements in R1 minus R2. We can do one thing. We'll find R1 intersection R2. What do you mean by R1 intersection R2? B is divisible by A, element should be from this, and it should be integral multiple of A is integral multiple of B. When will be A integral multiple of B? Only 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Because in all these cases, B divisible by A means A is less than B in all these cases. A is less than or equals to B. So, to make A is an integral multiple of B, only these 20 elements ma. That is 1, 1, 2, 2 and so on till 20, 20. We will be having 20 ordered pairs in R1 intersection R2. Okay. So, now what they are asking, number of elements in R1 minus R2, we can write it as number of elements in R1 minus number of elements in R1 intersection R2. R1 minus R2 is R1 minus R1 intersection R2, no? So, this is clearly 66 minus 20, which is equals to 46. Answer is 46, friends. Clear? Next question. The number of symmetric relations defined on the set 1, 2, 3, 4, which are not reflexive, defined on the set. First, number of elements in A. Number of elements in A is equals to 4. Okay. Now the number of relations which are not reflexive. Okay. First, total number of reflexive relations, friends. Number of reflexive relations, symmetry which are not reflexive means number of reflexive relations is 2 raised to n into n minus 1 by 2. So 2 power n into n minus 1 by 2 means 4 into 3, 12 by 2, 2 power 6. Okay. Next, number of symmetric relations. Number of symmetric relations is formula is 2 power n into n plus 1 by 2. So 4 5s are 20 by 2, 2 power 10. Now what we need, the relations which are number of relations which are symmetric but not reflexive mean 2 power 10 minus 2 power 6. So 2 power 10 is 1024 minus 64, which is 960. The answer is 960, friends. Okay. Next question. Let A is equals to 1, 2, 3, 4, R is equals to 1, 2, 2, 3, 1, 4 be a relation set, be the equivalence relation on set A such that R then the number of elements in S is n, the minimum value of n is equivalence relation. So to make it equivalence, what should be, like how many elements should be added? Same, almost the same case, friends. Okay. Now we'll see this. Question number 21. R is equals to, first to make it equivalence relation, it should be reflexive, no? 1, 1, 2, 2, 3, 3, 4, 4 should be there. Okay. As we have 1, 2, so 2, 1 also should be there, ma, to make it symmetric. 2, 3 means 3, 2 should be there. 1, 4 means 4, 1 should be there. Next, to make it equivalent, 1, 2, 2, 3 means 1, 3 also should be there. For 1, 3, 3, 1 should be there to make it symmetric. Now to make it transitive, let's see. 2, 1, 1, 4, so 2, 4 should be there. For 2, 4, 4, 2 to make it symmetric. Next, 1, 2, 2, 3. Next, 3, 2, 2, 3, 3, 3 is already there. 2, 1, 1, 4, 2, 4, 3, 1. So next, what else to be there? 4, 1, 1, 3. So to make it symmetric, 4, 3, 4, 1, 1, 3. To make it transitive, 4, 3 should be there. Now when 4, 3 we have, to make it symmetric, 3, 4 should be there. So that's it. So these are the elements of capital R. Now number of elements in R is equals to minimum it should be. So 1, 2, 3, 4, 4 4s are 16 elements, friends. There are total 16 elements in R. To make it the minimum number of elements to be in R is 16, then only it will be equivalence relation. Clear? Next question. Set A is equals to 1 to 100. Let R be a relation defined on A such that x comma y related only if 2x is equals to 3y, it seems. 2x is equals to 3y. B, acha. So 2x is equals to 3y means R, set R, ordered pairs of R will be equals to, see friends, 2x is equals to 3y means if x is 3, y should be 2. If x is 3, y is 2. If x is 6, 2 6 are 12, 3 4s are 12. Yeah, 9 comma 6, 2 9s 18, 3 6 18. Next 3 2 3 3, 3 4s are 12, 2 4s are 8. In this way you can keep on all see in first, in each ordered pair first elements will be multiples of 3, second elements will be multiples of 2, and so on. Last one will be in 100, no, 99. So 3 into 33, 3 into 33 is 99 and 2 into 33 is 66. So total how many ordered pairs do we get? Number of elements in R will be 3 ones are 2, 3 into 33, that is 33 ordered pairs you get. Okay. Now what this fellow is saying, let R1 be symmetric relation. Yeah, symmetric relation such that R subset of R1 and the number of elements in R, then the minimum value of n. So to make it symmetric, friends, to make it symmetric, we have to add 2 comma 3, 4 comma 6, 6 comma 9. So each ordered pair, for each ordered pair we have to add one corresponding element, correct? So number of elements in R1, number of elements in R1 to make it symmetric is 33 plus 33, which is equals to 66. Answer is 66. Okay. Next question. They have given two sets, friends. Set A 1 to 10, set B is from 0 to 4. The number of elements in the relation are such that 2 times of A minus B whole square plus 3 times of A minus B belongs to capital B, belongs to set B. Now let's take this common. So 2 times of, A minus B, take it common, A minus B into 2 times of A minus B plus 3 we have should belongs to B. Friends, A minus B into 2 times of A minus B plus 3 will be belong to set B only when either A minus B is equals to 0 or A minus B is equals to minus 2. No other case we get it, ma. See, suppose if A minus B is 0, 0 into something, that means 0. If A minus B is minus 2, minus 2 into 2 into minus 2, minus 4. Minus 4 plus 3, minus 1. So 1 into minus 4 is plus 4. Clear? In only this case, suppose if A minus B is 1, 1 into 2 1ja, 2. 2 plus 3 is 5. 5 into 1. So we are not having. So clearly A minus B into this belongs to be only for A minus B 0. A minus B 0 means A equals to B. And in this case A is equals to B minus 2. A equals to B means how many ordered pairs do we get such that A is equals to B? We get 1 1, 2 2, 3 3, 4 4. 1 1, 2 2, 3 3, 4 4. 5 5, 6 6, 7 7, 8 8, 9 9, 10 10. That's it. Okay, because A comma B both belongs to set A only. So we get 1 1, 2 2 and so on till 10 comma 10. We get 10 ordered pairs in this case. Okay. Now A is equals to B minus 2. In that case what do we get? A should be equals to B minus 2. So 3 should be equals to, 1 comma 3. Difference should be equals to 2. Okay. 1 is equals to 3 minus 2 in that way. Or 2 4, 3 5, 4 6, 5 7 6 8 7 9 8 10. See, B minus 2, second element minus 2 should be equals to first element. So in this case 1 2 3 4 5 6 7 8, 8 ordered pairs we got. So either this ordered pairs or this ordered pairs only will be in R1. So clearly now that means total 10 plus 8, 10 plus 8, answer is 18 friends. The answer is 18. Clear? 18 ordered pairs do we get. So number of elements in R1 means number of elements in this relation is 18. Next question. Set A is equals to 0, 3, 4, 6, 7, 8, 9, 10 and R be the relation defined on A such that R is equals to set of ordered pairs of X comma Y. The number of elements that must be added to R1 so that it is symmetric relation. Same story friends, it is symmetric relation. Okay. X minus y is odd positive integer. What do you mean by x minus y odd positive integer? X minus y odd positive means, suppose if I start 10, 10 3, 10 3, 10 7, only odd minus odd, 10 3, 10 minus 3 is 7. Acha, x minus 3, x minus y is odd positive integer. So 10 minus 3, even minus odd or odd minus even, then only you will get odd, okay, because even minus even or odd minus odd will always be even. So 10 3, 10 7, 10 9, 10 3, 10 7, 10 9, okay, odd positive integer, that too. Next we will go with 9, 9 0, 9 3, no, 9 4, 9 6, 9 4, 9 6, 9 8, odd positive integer. If I go with 8, 8 3, 8 3, 8 7, that's it, 8 3, 8 7. Next 7, 7 0, yes, 7 4, 7 6. Now if I take what should I take? If I take 6, 6 3, correct, 6 3, only 6 3, that's it. Next 4, with 4 if I take 4 comma 3, next 3 4 comma 3, next 3 comma 0. So these are the odd pairs that we have got. Or x minus y is equals to 2. Acha, x minus y is equals to 2 means, x minus y is equals to 2 means 10 8, 9 7, 10 8 we have, 9 7 we have. Next 8 6 we have, 10 8, 9 7, 8 6, 6 4, 10 8 difference is 2, 9 7 difference is 2, 8 6 difference is 2, 6 4 difference is 2, that's it. So these are the 4 ordered pairs such that x minus y is equals to 2 and 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now 15 plus 4, these are 15 elements and these are 9 elements, sorry 4 elements. Now what we have, what we are supposed to find, the minimum number of elements that must be added to the relation R so that it is symmetric relation. So that it is symmetric relation. See guys, now for each of them, for 10 comma 3 to make it symmetric, we have to add 3 comma 10. For 10 comma 7, 7 comma 10. That means for each corresponding element, we have to add one more element. Correct? So for 19 elements, 19 more elements should be added so that the relation will be symmetric. Hence the correct answer is 19. Okay? Next. Last question. So the number of relations on the set 1, 2, 3 containing 1, 2 and 2, 3 which are reflexive and transitive but not symmetric. Reflexive and transitive but not symmetric, it seems. Acha. So to make it reflexive friends, number of relations, okay? To make it reflexive, first 1 1, 2, 2, 3, 3 should be there. Okay. In 1, 1, 2, 2, 3, 3 should be there. And it reflexive but not symmetric, it seems. Not symmetric means 1, 2, 2, 3. To make it transitive 1, 3 we have to add. Okay. Okay, done. I am taking one more relation such that it consists 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3 should be there, ma. Now, it should not be symmetric, no? One more, if I add 2, 1 to this, then this is transitive, reflexive but not symmetric. Clear? R1 is same, R1, R2 are now reflexive and transitive but not symmetric. R3, I can form one more. 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 3, 1. These three should be there. Along with this, now I just remove 2, 1 and add 3, 2. Okay. Now if I add 3, 2, this for 1, 2 there is no 2, 1, no, so it won't be symmetric. Now it won't be symmetric and it will be transitive and reflexive also. So therefore we can only form 3 relations, friends. We can only form 3 relations which containing 1, 2 and 2, 3, which contains 1, 2 and 2, 3, and 3 relations are reflexive and transitive but not symmetric. Clear, friends? So friends, in this session we have covered all the questions from the chapter relations in the years 2024, from the years 24, 23 and 22. Okay. Now if you have understood all the questions, the pattern which is being asked from relations is very similar. How to check whether it is reflexive or symmetric or transitive. Okay. Make sure that you are having thorough and good conceptual clarity on these 3, like identifying how it is an equivalence relation mainly. So once you are clear with this, my dear friends, any question from relations, you will be in a situation to answer them. Okay. So we are always there to boost your preparation. Wish you all the very best. Good luck.